Today we'll see how we can answer this question, which is under the more concept. So these short types of questions are usually found in paper 1. So we can quickly answer this question in just under a minute. But before we do that, there's some information that we need to understand, or we need to get from this equation. We can get from the equation the ratios of the moles which are reacting. We can also get the ratio of the masses which are reacting. We can also get the volumes. So the number of moles are just the coefficients which are in front of these compounds or molecules or elements. So here we have 2. So it means we have 2 moles reacting. Nothing, so it means we have 1 mole which is reacting. Then with the 2 there, it means we have 2 moles that are reacting. When you look at the masses, to get the mass, which is here, I multiply the number of moles by the relative molecular mass. So that's 2 by 2, which is 4 grams. For oxygen, we have 1 mole, so 1 by the relative molecular mass or relative molar mass, that will give us 32 grams. 2 moles, so 2 by the relative molecular mass of water, which is 18, gives us 36 grams. So we should know that mass is not lost during a chemical reaction. So the masses of the reactants, which is this, should be equal to the product. So 4 plus 32 will give us 36. Of course, the moles won't balance, because here you have 2 moles reacting with 1, but still giving us 2 moles. But the masses should balance. The ones on the reactant side and the mass of the product should be equal. For the volumes, we know that the volume of 1 mole at RTP is 24 cubic decimeters. So if we have 2 moles here, it means the volume there will be 2 by 24, which is 48 cubic decimeters. This is 1 mole. So 1 by 24 is 24. Then this is a liquid. So we can't get the volume of a liquid, because molar mass, or rather molar volume, only applies to gases. Now let's go to answer our question. So our question says, what mass of oxygen will react with 12 cubic decimeters of hydrogen to form water? So they're asking for the mass of oxygen. So we should know that these ratios, we can always relate moles to moles, or moles to mass, or mass to moles, volume to mass. Whichever ones, they'll always be proportional. So let's look at this. We want the mass of oxygen, but I've been given the volume of hydrogen. So we can get the ratio or the mass of oxygen there, which is 32. So I'm comparing the two, hydrogen and oxygen. So they want me to find the mass of oxygen. So I'll get the mass of oxygen from the equation. And since I've been given volume of hydrogen, I'm going to get the volume from the ratio, which is 48. Okay? And since I want to find the mass of oxygen there, then for hydrogen I'll use 12.